Hi, everybody.
Hello.
Hey, Sean Ryan.
Hi, Greg, Keith. Today's topics are listed in the meeting document. So we're gonna continue the discussion of the DAS COVID that will be led by Ned, and this is the continuation from the meeting back in last month. And also there's in that meeting, there's an agreement like a day to discuss the endorsement versus reference. And then the few other things, right? So yeah, like the action items for the chairs. And also Dan, he has a request for volunteer for this update of the 6 work to the tag, but he's not able to attend this meeting. Right, so any other topics you guys like to cover?
Seems like a pretty full agenda.
Yeah.
Yeah, hello. From my side, I would like to have answer from the chairs. Like, my proposal has been around for quite a few months now, so maybe we can start with that a little bit before Ned joins. I think he's not yet in the call.
Yeah, I think even though the discussion started for for a while, but then in the last meeting, but so that's when we got the good discussion, and then in the meeting there's some like a proposal to refine the scope, right? And so is that reflected in the in that issue put together? Or?
Yeah, so the scope has already been reduced. So, and it's clear as Greg suggested. So it's only the formal verification part, and we dropped out the all other parts, which were which we might propose as maybe another separate proposal or something like that. So it's only talking about the formal verification of the part. So the only formal verification part is now included. And the relevance to the RATs is that we model different frameworks based on that, and then we verify them.
So based on the description you just gave, I added some comments to it just a little bit ago, just minutes ago, actually. And I think based on what you just described as your summary of it, I think they're pretty minor comments. But there are some things in there that I think are unclear how it would affect the effort of the that's being proposed. But if the effort is around creating the formal models and little else, I think that it's largely on the same page, and you're already in line with what my comments are implying.
Okay. Also, so sorry, I didn't saw your comments. I'm just looking into that. So but then I will respond to that. That's not an issue. So the high level idea is just the formal verification part.
Yeah, no fault of yours for not seeing the comments. I hit send on them just before I walked into the room. So
okay, that's fine.
So it's good. Yeah, there's an update and comments, and maybe we can follow up through that thread. Right. So now you have it updated in front of the issue.
Yeah, but it would be nice to hear from others as well. I mean, we should not wait for 2 weeks to have another set of comments from others. So if there are any concerns, I would like it to be raised right now, rather than having it like we wait another 2 weeks and then we have another comment. So whatever comments you have, I would like it to have it now, or maybe let's say a couple of days, so that I address them all and then we finalize it as soon as possible.
Yeah, I think the general or the gist of my comments are that like the proposal should, it can have like a motivations behind it, which may be what you meant by outcomes, but it should be very clear on what the expected output of the effort is. And if that is just the formal models, then that should be stated, and the other outcomes should be clarified, that those maybe are motivating factors, but are not expectations of an actual output artifact of the effort. But other than that, like I mentioned last week, I think the creation of the formal models, and even potentially their mapping to existing technologies in the space, is extremely valuable, and I think in scope for the SIG. So.
Yeah, that's fine. So the potential outcome number 4 basically contains that point: verification primitives, building blocks for sample instantiations for each of the 3 major groups. So that's what it is referring to.
Yeah, I left a comment on the wording of that fourth one,
okay,
and then
that's
the
fine.
other 3 I think are potentially not outputs of the effort.
Okay, sure. Then I will clarify that. Right.
But I think this is just a wording thing, and I don't think that it'll be difficult to get to a point to approval, at least from me.
Yeah, one thought on my mind is it seems like some of the wording is kind of open-ended, and
Yeah.
that's a bit scary to me in terms of, like saying, yes, we bought into this open-ended, potentially infinitely scoped, project that lasts forever. And I would, I think in terms of motivation, like, hey, there's this open-ended problem. Yeah. But in terms of like, hey, what are we going to work on now? What is the specific measurable scope? What's the, making it not open-ended would make it a lot clearer to me in terms of what I was saying. Yeah, it makes sense that, for folks to think about, to be working towards, versus the open-ended stuff. So, and the things I've heard is about defining formal models. So it'd be lovely from my perspective if, somewhere in there's a very clear section that says, this is kind of like the specific work, and it's expressed in terms of formal models, and not open-ended formal models, but formal models that achieve A, B, and C, where A, B, and C are clearly measurable and clearly scoped to something that's tractable, in 6 or 12 months versus a decade.
100%. Yeah, thank you for, I think that stated what I was trying to say a little more succinctly.
So I have the same comments. Basically, I find Usama, the core very good, and some of the parts, some of the prose a bit distracting and uselessly so. I think if you just remove some of the points there that are not, as Greg said, measurable, or they're just aspirations rather than achievable targets, then we are good to go. It's just wordsmithing to me. The core is great, and I think is very valuable and very in scope, as I said last time. So I don't know how to phrase this, but it's good to go as soon as the redundant thing or the non completely useful things are removed from your proposal of work. That's it.
Yeah, I also agree with the comments from Keith, from Greg, and Thomas, right? So, and we don't need to wait for the next meeting in order to to move forward. And I think this the issue, the comments in the issue is a very good phone. So we definitely can make progress. By commenting in that issue. Right? So as soon as you have an update, then maybe we can, check back.
I'm wondering whether it would make sense to have, a half an hour altogether to wordsmith the charter of work and be done with it, rather than waiting on Usama on the updates and then another round of comments. But brainstorming together how to refine the charter.
So do you mean setting up another meeting instead of work on?
Yeah, I mean, having a half an hour between the four of us, the five of us, and close the issue basically by working together at the wordsmithing parts.
Yeah, that would be great, I think.
Yeah, I can certainly make the time to support that. And that's potentially the quickest way to get to focusing, I think, the proposal.
Great.
But then there's that it not work, right? So to be done based on the comments you guys just provided. And then I think we can, so if like the comments can be, this proposal can be updated, then maybe we don't need that half an hour. If there's a need, I definitely can support that effort.
Yeah, but we haven't been successful with the iterations. There's been I think a handful of iterations, and they kind of continue going on. So I'm personally not convinced that if we're potentially not talking with that really high bandwidth kind of immediate communication, that we might not close on this quickly. That's just my thoughts. I mean, it seems possible we could, but we've had a few iterations, and there's clearly, I think we're still all kind of coming together in terms of getting on the same page as to what we're trying to achieve here and what makes sense to folks.
Yes. Also, I don't want to frustrate Usama, right? He's put a lot of effort in.
Yeah.
So I can make time if Greg, you can together,
I'd be happy to as well.
Right.
Yeah,
Okay.
I can free up half an hour. So just somebody pitch a few whatever times, dates, and we can
Okay.
pick or something like that.
Cool. Let's take this
So
offline.
who will take this action item to find a time?
I will.
So Thomas?
Yep.
Thank you, Thomas.
Thank you.
Okay, that's cool. So let's switch to these other topics. So net. So you'd like to
Yeah, I'm
take
here.
over? Yeah, to continue the discussion.
Sure. Okay. Let me share. Okay, let me sure you can see this.
Yes.
So this is, I think, the third sort of extension to the topic on CORIM. And if I remember last time, we kind of started the conversation about the CORIM structure. There were other related topics to, DICE and DPE and stuff like that. And so, but then we sort of got into the conversation of, how does a verifier determine that a DICE layering is a proper layering, and that got us into CORIM. And so we started digging into the CORIM stuff. I want to provide enough context that everybody that if some people are new, that they can sort of dive in, but also not redo the whole presentation. So is it appropriate to just start here at the CORIM top level and start digging into that at that point, or does anybody want to see more of the other slides?
That seems reasonable to me. If people have questions, maybe that could back you up, but starting there seems good.
Okay. So just a high level overview of what we mean by COREM. There is if I refer you to the RATS architecture document, which is now an RFC, there is something called reference value provider as a role, and then reference values, which is a message that the reference value provider communicates to a verifier, which is then used to compare or match against evidence. And evidence is a set of values that comes from the attester to the verifier. And so it's this basically matching these two structures together to determine if the attestation evidence is valid or not. And so this is the reference value, a structure that we could stereotype as a reference value. In the context of COREM design, it also can be used to represent another information flow, which is an endorsement. That is something that an endorser, the endorser role produces. So the COREM schema considers both. They can be separate or combined. It's kind of up to the implementer to determine what parts of the schema they want to implement to satisfy that role message. And so the kind of the history behind COREM is that there were some folks early on looking at something called co-SWID or SWID, which is software ID tag. And the idea behind a software ID tag is there ought to be a structure that can represent a software package or component in a machine readable schema representation. The original SWID work was done by ISO, and it was implemented in or described in XML. Then folks came along and said, let's take that schema and represent it in a more concise way using something called co-SWID, and co-SWID is based on a CBOR or JSON encoding. So, and the idea being it's a little more concise than XML. So some of those same folks got together and said, hey, can we use co-SWID to represent other things besides software, such as hardware and hardware roots of trust? And the short answer is, hey, it's really challenging. It might be possible, but it's hard. And so that was the genesis for this thing called co-MID, or concise module ID tag. And from that, the COREM structure kind of evolved, where the idea is to say, well, let's take the goodness that's in co-SWID as a software tag, and the goodness in co-MID as essentially a hardware tag, and create a RIM around them, which is a signed object, a signed data structure that could represent both of them. And in fact, the approach here is to make the tag structure extensible, so there could be other types of tags that could be added on later. And in fact, I think there is even a IETF draft now that would use that extension point to add another type of tag for trust anchors. So now we're sort of at the top level, and gonna drill down into it. The basic idea here is I have a COSE signed document that has some manifest level information in it, particularly a manifest identifier, and then a manifest locator. The idea behind a locator is to say, hey, if I'm in possession of a RIM and the RIM author happens to be aware of other RIMs that might be interesting or related, they have the option of providing a hint or a pointer to those other RIMs that might be relevant. but it is not trying to replace fully like a directory or some kind of discovery protocol, which would identify all of the necessary attestation information that's needed for a verifier. And then there's the tags section, and like I said, you could have commit tags, COSWID tags, and it's extensible. There could be other types of tags that are defined, and all of that is signed. So we could drill into COSWID. Chose not to do that for this presentation. COSWID has been around. I assume some people know about it, but we could drill it. And that could be an area to go dig into, but currently didn't prepare for that in this presentation. The other type of tag is the commit tag, and so the semantics for a tag are essentially that anything within the tag is some way related to the target environment that is being attested. And so there's some tag metadata, which is going to give you like a tag ID, and well, there's the tag ID, and then there's some additional metadata, which is going to have like a tag version number. And then there's this section called triples. I'm going to go into that in more detail, followed by something called linked tags relationships, which is to say, hey, if there's a set of tags that are all describing a target environment, or maybe you have a composition of objects that represent the target environment and you want to link them, then there's a way to explicitly do so. Otherwise, the assumption is that different tags are not related to one another.
Question?
Yep.
So the tag here is not the same as the CBOR tag, which is a number.
In a commit, it's not, I wouldn't say that it's a CBOR tag. That could be confusing because there's the notion of the CBOR tag registry, which is a special kind of CBOR tagging convention.
Okay.
This is a different kind of tag. So think of it as the commit tags are different from CBOR tags, although within the schema of commit, we do use CBOR tags. The convention is that a CBOR tag is described by # 6 dot something, and the something is the tag ID. But then there's an IANA registry that disambiguates what the various tags mean and the data structures that follow them.
Okay. Thank you.
Okay. So as I was saying, that the tags are unrelated unless explicitly related, and so you use link tags relationships to link them. And then we have this section called triples, and triples are expressions that describe deeper relationships between the attestation information. In this case, we're talking about either reference values, endorsed values, but there can be identity values and key values. And triples are extensible. So the idea is that there could be really rich expressions about relationships between sort of attestation information in the triples. So the 4 that you have here is sort of the starting gate set, and there are others that have been added since this slide was developed. So drilling down into the reference triple, it's basically the structure. The intent of the triple, or the name triple, is derived roughly from the RDF work, which is there's a structure that if you're not familiar with RDF, it's basically a logical structure for modeling information, and so there's the basic structure is a 3-tuple that consists of a subject, an object, and a predicate. And the predicate is some semantics for relating the subject to the object. And so we can see that here in COMID, the predicate is not explicitly stated in the schema. It's essentially documented in specification, and only the subject and object are explicitly stated here. So, and in this context, the objective is for the triple to relate a target environment essentially to a set of measurements that belong to the target environment. And so it uses terminology like environment and measurements. Now, each of these statements are a tag value pair kind of combination. So there'll be for the environment, there'll be something like a class name, which is a tag value pair, but it's just trying to describe class attributes. So just to read this, so in environment, there's an extensible list of there's a list of environment names. This one shows the class name and an instance name. Later on, there was a group name that was added.
Hey, Ned, it might help, but could you just give an example of what one of these triples would, like a concrete example of what one of these triples would represent?
So think of in the context of dice, for example, a dice layer, we think of as a dice layer, would be a target environment. And so if the layering is part of, say, a boot path, then there's going to be maybe there's a bootloader, which is loaded by some ROM code. The bootloader is firmware that has a digest, and so we would have a class name that maybe it's an OID or a UUID that refers to a particular bootloader, and then the measurement value is going to be the digest of the bootloader.
So what's the subject, object, and predicate?
The subject is the class name, for example. So maybe maybe you have a UUID, which would be the class ID, and the vendor X, which is the one that's sort of in charge of the UUID namespace. So you might populate class ID and vendor. There are these other ones that are optional to use, but essentially it identifies what that measurement, it identifies what measurements are appropriate for the target environment.
So what would the subject be? What would the predicate be? What would the object be?
The subject is the environment, which is to say this dice layer, or this bootloader. The object is a measurement, which would be the digest of the bootloader. And the predicate is pretty straightforward. It's just saying that this bootloader X has this measurement.
Okay. So layer has measurement is kind of what a typical triple would be. Okay.
Yeah, basically.
Thank you.
A related question. Question to that. So I'm wondering, what are the other possible predicates? Like, is it only the possibility that a specific target environment as the subject has a specific measurement as the object, or is it a possibility that there are some more complicated, let's say, predicates that are expressible? So what I'm trying to understand is that what is the expressive power of these predicates?
So because the predicate is not, we didn't try to capture it in the schema, it's really anything. Any predicate that you can imagine is possible. It just has to be documented somewhere.
Okay, and the one who is verifying, how would that know that what was the encoding scheme? Kind of, for instance, let's say if it's not a subject-object relationship, which is just one, so how would the verifier know what was encoded at the encoding time?
The specification, they have to read the specification to get that.
Okay, right.
Yeah.
Basically, Usama, is each triple has a number, right? That is standardized, and that number is the triple meaning. So if the verifier understands that number, then it knows the semantics associated with that and can do the matching, the correspondent matching.
Okay, so for a specific predicate like that, the target environment has this specific measurement, there will be some number associated like 1. And if I want to define something else for that specific predicate, I will use another number 2, and so on. I will build that kind of specification, right?
Yes, because the triple space is extensible, and therefore you can add new triples with new semantics that you want.
Okay.
You need to document them and register them in order to make them available to everyone. But otherwise, you could also have, private triples that are only understandable within your environment, for example.
Right. Thank you.
You suggested that a triple is registered if it's of, general utility.
I'm a bit lost because we're talking about triples, yet I only see in the schema a tuple or a double, two entities. So
if we take the reference, if we were to add the predicate, I don't know if you can see my mouse.
yeah, I can see it.
Okay, if we were going to add a predicate in the schema and have some sort of description of the predicate, maybe the predicate is has, maybe that's our predicate. We could define that in the schema and just say, okay, this uses the has predicate, and make this have 3 boxes instead of 2.
Yeah.
So it's subject, object, and predicate, and we're just the third part is implied down here.
Yeah, the part that confused me was, I understand that the schemas uses includes two of a triple. But so mechanically, I imagine I can only express a tuple or two values, and yet I heard Thomas and Osama discussing, we can distinguish different predicates by using a number 1, 2, 3, 4, 5, 6, 7. I didn't follow that. I don't know where 1, 2, 3, 4, 5, 6, 7 happens with.
The predicate is not pluggable. The predicate is basically statically encoded in the triple. So the reference value triple has always the same predicate, which, as Ned said, is has. Subject has object. Environment has measurements. Another triple will have another predicate, but that would be encoded with the triple itself, right? Stashed inside the record implicitly.
Are you saying that in that list on the middle where I see reference triples, endorsed triples, identity triples, there's some way to distinguish different types of triples, and so essentially the type of triple becomes identifying the predicate. So we'd have Thomas triples, and that implies whatever Thomas says his predicate is.
Exactly.
Okay.
So if you're not familiar with CDDL extensibility, basically there's a set of code points. So in a CDDL map structure, each entry in the map is distinguished by a code point, which is like a label and a number. And extensibility just means that you can add new entries into the map structure, and each one gets a different number and label. If it's CBOR, then the labels get thrown away, and you just use the number, and that number then becomes part of the CBOR encoding. And so,
do all I'm assuming that the triple types I see up here, reference, endorsed, identity, attestation key, are all of those have the same predicate, which is essentially, I think we said was has, like subject has, or environment has measurements?
essentially, yeah.
Okay, so it would be a bit is Usama's example where there's a different predicate expressed in a different triple type? Is that kind of anticipated and common, or is that kind of an edge case?
So it's allowed, and we're having some discussions right now about how best to represent, SGX use cases. The SGX use of a triple is a little more complicated, and we're trying to work through that. All of the
Can I ask-
examples. Yeah.
Ask the obvious white elephant question, or why wasn't the predicate included in the schema? So this other seemingly more less self-documenting way of kind of capturing a predicate is the way to do it.
The short answer is and I'm not the expert, but the short answer is that the RDF community tried doing that, and they ended up with some explosion of triples in order to capture, a bunch of different types of predicates. So we just saw a predicate explosion, which resulted in triple explosion, which then became unwieldy, and you had it's sort of to the point of, hey, this makes it harder than what is just do the obvious thing, right?
Okay, cool.
And so you just sort of death by 1,000 cuts kind of thing. So we're just trying to avoid that, and who knows.
Yeah, cool. Thank you. Makes sense.
All right.
I have one related question. You mentioned that there is an ongoing effort for SGX predicates representation. Can you maybe later on share some link or describe maybe which specific group or which?
Yeah, I can point you to the COREM repo where all of that's going on. It's all public.
Okay, and they are working on SGX.
Yeah,
I was specifically interested in SGX effort, which is representing.
Okay,
thanks.
Yeah, there's just a big thread going on there. Welcome to join. So here's some more examples. Take the identity triple example, right? So in all of the base COREM examples, the subject is always this environment structure. And so in a sense, you can relate all of these triples together, because if they have the same environment structure, then you're essentially saying, key off of the same environment structure, and then add a set of measurements that are interpreted as reference measurements, add a set of measurements that are endorsed value measurements, add a set of keys that are used for identity, add a set of keys that are used for attestation, etc. So you kind of have this tree structure, if you will, or a hierarchy that's keying off of the environment. All right. There's some additional ones. No, there's there's some additions to that where there's a triple that relates a coast mid to a coast SWID. And so again, keying off of the environment, we can say this target environment has a coast SWID tag that is saying that this target environment has this software package. So maybe if our bootloader was really complicated and we had lots of moving parts, we would choose to encode it using CoSWID instead of just a singleton, hash value, singleton digest value. And in which case, there's a way to relate that target environment to the SWID tag. But we could have other types of triples that aren't dealing with the target environment. So we have one that's describing a domain, which is a logical structure that is used to group environments. So I could say something like, hey, I've got my hypervisor is launching multiple VMs, and I want to relate them to one another. And so I could say, well, this set of VMs are all part of the same domain. but I can use different environments for each VM, but I want to group them. So that's another way to think about triples. Another way, another triple is described here is describing trust dependencies. So maybe I want to say that I've got, multiple VMs, but I also want to say that these VMs are tied to a particular, VMM, and that there's a trust dependency that the VM has on the VMM. And so I can model that this way by just saying, here's a VM domain that depends on a VMM domain. And I'm just using these examples out of the air, right? But like I said, it's extensible. We can add more. So now switching to the measurement side, this is the object side for most of these. In the measurement side, there's really some ways to sort of partition measurements. There's sort of class values that are sort of, you can think of them as class values, and others that are sort of instance values because they have uniqueness properties. Most of the interesting use cases are around class measurement values. So this is things like, version, SVN, digest of a bootloader. There could be, millions of bootloaders that all have the same digest, so it's still a class thing, even though it seems like it's pretty unique. But there's the sort of version, SVN, flags, digests, and then raw values, which is to just say, I decided not to digest this value. I'm just giving you the straight up value. Maybe it's a fuse or something. And there could be more. This is extensible. We did decide to include instance measurement values as well, or at least a few of the well-known ones, like a MAC address, IP address, serial numbers. But these are all, these are all sort of in the same measurement values map structure, and that map structure is extensible. So the expectation is that, if you can't satisfy your use case with these sort of basic building block ones, you can extend it to include the ones you need. So switching gears to concise evidence or evidence. One of the goals is, in terms of the verifier, is to relate the reference values to the evidence. It's easiest if there's a common schema between them. Although in the case of DICE and the work that TCG has done, there's an X509 certificate extension that has evidence values in it that sort of roughly matches these values here: version, SVN, flags, digest, and raw value. So TCB, it's called DICE TCB info. It's an X509 extension. It defines these same values. And so there is some, in that sense, there's some semantic overlap between the evidence and the reference value. But the encoding's different. But ideally they're the same, and that just minimizes the amount of sort of extra work that verifiers would have to do to get that to do the matching. This is showing some work that's being done in the TCG to define an evidence format that's based on the co-mid schema, and it also is accommodating the SPDM protocol, which is a conveyance protocol that contains measurements. One of the challenges there is that the measurements are not the expectation is that the SPDM requester kind of knows what the different measurements are of. And so they, in that protocol, they just have a measurement block, which is an array of measurements, and it's up to the SPDM requester and responder to somehow have agreed upon what object or what component the measurement belongs to. That's outside of the scope of the definition. So what this work was trying to do is to add essentially a table of contents and a schema description that relates the measurement values to a target environment. So we're essentially trying to take the top half, trying to take this sort of top half subject and relate it to the measurement, which would be the object. That's what this is trying to accomplish. And so it defines a structure called a concise evidence map, which is just a list of evidence triples that are structured roughly the same as the commit triples. And so you essentially have reference triples schema, which essentially inherits from the reference triples schema from the CORIM schema. And so that's all it's trying to represent here, is that there's this inheritance mapping. I think that's kind of what I had prepared. I mean, there's a bunch of detail if you sort of dig down into each of these structures and chase them down, to the terminus representation. It reads a bit like a BNF grammar, and so you're sort of chasing things down to bytes and strings and stuff like that. But otherwise, it's these are the main kind of logical constructs that we have to work with.
So thanks, Ned. What's the status of putting these ideas into action in terms of actual systems that are out there running? Is any of this running any? Go
yeah.
on.
So Thomas is like driving the Verizon project, which is an open source project that implements all or most of this stuff. There's work in flight.
Doesn't that also require, because like the CORIM stuff is a way for, as I understand it, it probably does a whole bunch more, but one thing it does is allows the hardware manufacturers to share reference values or endorsements with verification services, and Verizon's a verification service. So doesn't there also have to be the flip side of someone producing, doesn't Verizon consuming this, but there still has to be a producer? And who's that producer?
Yeah, so Verizon, I view Verizon as an open source project that provides building block tooling.
Mm-hmm.
A verifier is also a building block, but an endorser could use those building blocks to generate a CORIM that contains endorsed values. A reference value provider could use it to produce a RIM that creates reference values and so forth.
Oh, so my notion of the Verizon project is incomplete. It includes building blocks for not just building a verification service, but for parties such as hardware manufacturers that want to produce CORIM bundles for them to do that.
Sure.
And
yeah, they could. I mean, Thomas can speak up, but yeah.
Yeah, correct. So we have the CORIM library. We have the command line interface tool that allows you to assemble these things from JSON templates. There is work going on the device side from TFM to produce automatically CORIMs out of at build time for the device. So during manufacturing and in various stages.
I'm not familiar with the device you're speaking of.
TFM is trusted firmware, so is trust zone based IoT basically,
okay.
and not just that, because yeah, for now it is TFM. It could be TFA easily, and therefore then you scale out to devices like phones and stuff like that. More things. I think we're looking at small things and how to produce core MZ build time from the build environment. Yeah.
There's also some tooling that's actually used in the repos to write the tests for checking the CDDL accuracy. And so you can that tooling allows you to author like a RIM. You can create a co-RIM. The tooling supports CBOR Diag as one of the RIM formats. It seems like there might be tooling for a JSON representation as well. I'm not that familiar with it. And then that tooling will generate a CBOR RIM structure, which is the binary representation as the output. Yeah. So that
I guess in my head, what I'm trying to piece together is, there's a set of parties out there that, are the folks that will be providing reference and endorsement values. They're those entities.
Yeah.
Who are they and where are they in their journey to potentially using co-RIM as a mechanism to share these endorsement and reference values? And I imagine it's kind of all over the map, but I'm just trying to get a sense of, where the world is in this journey, because this is painting, a proposed, in my mind, is painting a proposed coherent, beautiful picture for, a complete universe that functions using these structures. Yeah. And I'm just trying to get clear in my head, where does the people who have to adopt it, where do they stand? Are they aware of it? Are they committed to it? Have they written any code to it? Do they plan to write code? And that's the ultimate question in my head.
There's three communities that we can talk about. One's, I'll call it the root of trust community. There's the endorser, reference value provider, manufacturer community, or supply chain community, and then there's the verifier community. And most of the early work is, the root of trust community is kind of leading the way in some sense, because they're the ones that have to build attestation support into their implementations, their root, into the roots of trust and the subsequent, layers. So there's a bunch of DICE work going on in the industry. I don't know if there's someone from Microsoft here, but Microsoft kind of has led the way for the DICE work early on, and have been working to enable the IoT community for attestable IoT devices. And then there's like the Microsoft attestation service that's tied to Azure. I can't remember the exact name here, but so there's kind of an ecosystem going on there. Intel's been obviously working on roots of trust technology built into all of their products, and I'm not up on what all of the different released products are, but there's Sapphire Rapids is released. There's support for DICE roots of trust in that. SGX is out there. It's a different kind of root of trust, although I don't see that there's a whole lot of, I think there's a case to be made that argues for SGX is a DICE root of trust layering structure. I think it could fit. But mostly the work that's going on there is to encode the evidence in some way. And so evidence encoding for the most part has been based on an X509 representation as an extension to the device certificate and the layered DICE layered certificates. That could be changing as we get more concrete around a schema like COMID.
Yeah. Just speaking for myself, writing code in the Azure Attestation service, where we currently support the AMD SEB SMP stuff. We support the Intel SGX and upcoming TDX stuff. We support some TPM TCG log stuff, et cetera, et cetera. You know, I see opportunities for co-REMs to be used, you know, to provide, you know, trusted values in the verification service, and that's not how things are structured. So in kind of the subset of the universe I've hit, I haven't seen any co-REMs, nor has anybody been speaking of co-REMs. And I'm just wondering, you know, when does the rubber hit the road? When am I going to encounter a real integration scenario with somebody out there that actually says, we want to share this with you, you know, in a co-REM, or we offer to share this with you in a co-REM.
Yeah, so I mean, it's sort of a chicken and egg proposition where the standards, you got to have standards in order to implement a product that meets the standard, and you know, the standards folks, you know, need to have implementations in order to call it a standard, and so you just have to work through that circular dependency.
Yeah. And where does the co-REM specification, where does that stand in terms of standards? Is it draft?
So TCG has something called the endorsement architecture specification for devices. That's public. It's basically done. So
Okay.
someone could implement co-REM based on that spec. The description, you know, the normative, what's normative is prose, and CDDL is in the appendix, which is not normative. The IETF co-REM is an adopted draft, and in that draft, the CDDL is normative, but it's still in draft state.
Okay, thank you.
And in particular, co-REM was adopted, I think, became a working group document in July of last year, and it's still at 0.0. So consider this to be the very first version of co-REM, and so in that sense, it's still early in the publication process.
All right,
It's early in the consensus process. That is probably a better way to phrase it. So
yeah, but it sounds final in TCG, and it's step one in consensus in IETF. Is what I think I heard.
Yeah,
correct. The IETF, I would say, Ned, I would say that IETF has consensus to publish something derived from co-REM, but it does not have consensus on the current state of the document because it's just a draft 0.0.
Yeah. So well,
So
obviously we're hoping to keep the standards, the different standards aligned. We don't want to have a bunch of, you know, variants that are all non-interoperable or whatever. So hopefully that we can get consensus in the IETF to basically keep things about the way they are. So
the jury is still out on that. So yeah, let's have that discussion at IETF.
Sure.
So time-wise, we are top of the hour, and this has been a very interesting discussion. And so Dave, sorry that we don't have the time for your agenda item this meeting. Let's schedule it for the next one. Any other questions? I think people will be dropping off.
I have a quick question about SGX, and how would you, or what is the current way of thinking about, for instance, the report data field, which is not let's say reference value, which is not endorsed value, but rather provided by the user. Where would it fit in this schema?
The report data, that's part of evidence, right? So
yes,
So-
that's parts of the evidence, but it's
I mean, I think we're over time. I know I have to go. This is an interesting thread. Maybe one of the follow-ups might be to sort of point to the co-REM repo, and if people can join in the conversation over there, maybe.
yeah, I actually added the links to the repo and also the issues for this new type of triples, right? So to the meeting minutes.
sure. Thanks.
And then
Okay.
the last agenda item is that we need the chair for the next meeting, so. Any takers?
I wanted to take it, but I'm not sure I will be there. So I can take it tentatively, but I might have to drop it on someone else if I discover that I'm not gonna be available.
I can back you up, Thomas. So if you
Okay,
yeah.
Thank you, Greg. So
Okay.
I can take it, and then if not, Greg will supplant.
Okay.
Excellent. Awesome.
So with that, I think if so as I mentioned, I put the links to this meeting minutes, right? So, and as mentioned by Nat, so we can have a discussion either in these forums in these meetings Slack, right, or in those issues and PRs in that current repo. Okay. So any last minute questions before we close the meeting?
No. Cheers, bye, Shaway. Thank you very much.
Yeah, thank you guys. Then we're closing.
Thank you, Ned. Thank you. Bye.
Thank you. Bye.